Okay. So now you can see the contour line of a cone is a series of circles with the same center, and you can see at every point in this in the surface of this cone has the same slope. Can you understand this? Every point on the surface of this cone has the same slope. So how can we think about this? So I will show you an example. So please think about it, how the cone shape. So here, how can we draw a cone? So I will do an example. Okay. The cone is a line that you can see. The cone is a line that rotate with another line. This line is x. And this line rotate with this line, so we can get a coin. So now please see. Please see it. Okay, so you can see I rotate this line, and I can get a cone. A surface. I can get a surface of the cone. So now you can understand every point on this cone. Has the same slope with what? Okay. So you can see every point in this surface, on this surface, has the same slope with this line, with this line. So it's a very important property for the surface, for the cone surface. Okay, let's come back. Okay, so now you can see as for this one, it's like the front wheel is like a triangle, and as for this one, the x this one x, the x is not vertical to the horizontal plane. Is not vertical to the horizontal plane. So this coin, the slope of this coin are not the same at every point. So this, you can see the slope in this line is the same with this one, and for this one is the same with this one. But as for the other part, they are not the same. This is the x. The x is not vertical. So, but at the same time, they are still combined with a series circles, but they don't have the same center. This circle don't have the same center. So this is irregular curve, irregular cone. Okay, as for this one, so who can tell me what's this? This is a cone, and this is like a hopper. Hopper. I don't know. I'm not sure if this translation is right. Who can tell me how to express how to describe this shape? Is this a hopper? Which one can tell me if I translate my translation is right?
Yes, it is larger.
Okay, so I would I say it is a hopper. So this is a you can think about it is a cone that with a different direction At the top of the hopper is a big circle. Is big circle, and then smaller with the descending of the elevation. Okay, so you can see this is a shape like V, like V. And as for real things, a cone, you can imagine a cone is like mountain. Is like a mountain, and this point is a top of the mountain, and also this one is also a mountain, and this one is a top. But as for this shape, I think you can imagine like it like how to basin. I think it's a basin. the 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 center of this shape is lower than others. So you can see it is the bottom and this is the top. This is the top. So that is the properties of the uh, the surface of a cone. Surface of a cone. So now we have learned about the contour line of a cone. The contour line of a cone is a series of circles with the same center. And now we please think about this problem. This is an example. Now we constructing a dam with an elevation of 8. You can see the top of this dam is the 8. Its elevation is 8, and then the ground is 4. And you can see we can we already know the top the shape of the top of the dam. So how can we get the other parts? So we want to know the top view of this dam, and we are going to draw the lines like the slope, the intersection line that with between the slope and the ground. So you can see at the center of the dam is a cone, is the surface of cone, and this contour are parallel to each other. Although they are circle, they are circle, but they don't cross with others. So we think that it is also parallel. It's also parallel to each other. So like this. Uh, so how can we draw this one? So how can we get this one? This line and this line and this line. Also, the difficult one is this line. Is this one, the intersection line between the cone surface and the plane. Okay, so I will show you how to draw it. It's just like your homework. The third figure of your homework. So at first, we are going to find the slope. We are going to find the difference of the elevation h. So at the first one, you can see the top of this dam is 8, and then the bottom of this dam is 4. And so what is h? So I think, yes, h is equals to 8 minus 4. Is equal to 4. Okay, so now we know the distance. We know the difference of the elevation, and you can see it is 1 to 1. The slope is 1 to 1. So how about the horizontal distance? The horizontal distance is 4. Yes, it's it is also 4. L is equal to 4. Yes, I think you have you know how to use slope, and I'm very happy. So now you can you can see the horizontal direction is 4. It means that this curve, and this curve, the interval between these two between these two curves are what? Can you image? Can you understand? This is also 4. Really? Yes, 4. So we can at first we can find the center of this circle. The center of this circle. Use your compass. You can use your compass. Find the center of this circle, and then we can use the scale ruler, and this one is already known, and we can use this distance added 4, and we can use the compass get this circle. Okay, now maybe you can understand. So it is the same with the plane. The plane is a line, and the surface of a coin is a circle. So when you want to draw a line, you will use the ruler to measure distance. And as for cone and the the circle, and you have to use your compass to measure the distance. Okay. For example, so this one is easy for you because this is 4. This one is 4, and for this one we have used the compass. And for the first step is find this distance. Is to measure this distance, and then we added 4 and this distance together, and this distance is the already known added 4. So this line, this circle, we can use our compass to draw this circle. Okay, so now please, do you have compass in your hand? If you have, please use your compass and do this exercise. So it's very easy. You can just draw this line. You can just draw this line at first, and then you can also draw a scale ruler, and then use this as a center and then use your compass, measure distance already known at it 4, so that you can get a new one. Okay. Okay, I think this is not difficult to understand. Okay, so I gave you 5 minutes, 5 minutes to think about it, and you can draw it by yourself. You can draw it by yourself. Practice. Oh, so at first you can only practice this one, this circle, or this one, and then I will tell you how to draw this one and this one, this one. Okay, I think so. You'd better to prepare your pencil, your compass, all time. Okay, so his time is not enough. So then I will tell you how to draw the other part. Okay, so because this part, this one, is this distance. This distance is 4. Okay. Distance is 4. For this distance, and so between the 8 and 4, and we can divide this surface by into 4 parts, and each line is the interval of each line is 1, because so you can see it is 8 and it is 7 and it is 6 and it's 5 and this is 4, and then you can divide this line to this interval also into 4 parts, because the interval of these 2 lines are 4. So each line is 1. So this is 8, this is 7, and this is 6, and this one is 5. Okay, so and then we are going to find the intersection line of the cone and the slope. So we have the intersection line between two planes. So that I think the step is the same. The step is the same. So prolong this line and this one, so you can get a cross. You can get a cross point. And also you can, with the same procedure, you can get another point, and another one. But please remember, this point are not at the same line. Are not the same line. So it is a curve. It is not a straight line. Please remember this. A plane, a cross section, a plane crossed with a circle, with a surface, with a curved surface. The intersection line is not a line. So you can connect these 5 points, and you can get the intersection line. Actually, it is a curve, but we can't divide it into a very small part. If you divided this interval into 40 parts, and also you can also divide it into 40 parts, and you can get 40 cross points. You can get 40 points, and then you connect these 40 points together, and you will get a better line. You will get a better one. It is much more. It is much more like the realistic. But usually, it is not efficiently. It's not efficiently. Because if you tell me, please draw 40 lines in this interval, and I will get boring, and I will be very tired. So as for as for our homework, and as for the engineering drawing, so it depends. So you can draw 3 or 4 or 5 lines between these two lines. Okay, so so can you understand what I said?
I have a question.
Okay.
In the first part, this distance, distance here,
Okay.
from the center to somewhere down here, are we supposed to use the scale or just use the initial distance? For example, if it's 4 meters or 4 centimeters, we just use the ruler to measure the 4 centimeters, or we're supposed to use the scale?
The initial one is this, and then we want to get the line at the bottom, and we already know the interval is 4, so we use the initial one and added 4, and this is the radius of the big circle.
Oh, okay.
Okay.
So we're supposed to use the scale.
What?
We are supposed to use the scale.
Oh, you
the scale ruler.
The scale ruler. Oh, the scale ruler is. Now you can see this scale ruler is 0 to 4. It means that this interval, this segment is the distance of this segment is 4, and so you can put this ruler here. Use this ruler, measure 4 unit. Okay, you understand. So you can see if we use CANVAS to draw two circles. The first one is this one, and then the big one is this one, and so they are in the same they are in the same cone like this, or they are same one like this. For example, you can imagine this circle is like this, and this one is like this. So the difference of the radius of these two circles are the same. So at each point, there are four. There are also four, because they are the circle with the same circle, with the same center, So, how about my explain?
Yes, I understand.
Okay. So let's come back. Look at this one. So if you can draw many lines between the top and the bottom, and you will get much more points, and the more points you get, the more realistic curve you'll get. So you have to keep a balance between the work and the accurate. Okay, so that is the surface, the cone surface, and the plane, the cone surface and the plane. Okay, so let's start. And so please look at this one. This is okay. So how can we clean this ink? This one. Okay, so please think about it carefully, and now you will know how to. Now I think you already know how to draw this homework. Okay, please think about it for 2 or 3 minutes, and I will tell you how to draw this. Okay, so please follow me. Please follow me. And so at first, you can see this is our homework, and here is a plate. Here is a plate, and here is the bottom. Here is the top of the plate, and here is the bottom. Here is the bottom, and you already know the slope of each surface. And as for this one, is a circle. Is a part of the circle. Okay, so now what should we do? So at first, now you can see we already know the slope. We already know the slope, and please find the please find at first. Please find the difference of the elevation is what? The difference of the elevation is 3. Oh, is 3 minus 0. Is equal to 3. Okay, so it's very easy. It's very easy. And okay, and as for this plane, because you can see this is the contour of this plane is a straight line. So it is this part is plane. So now please draw a shape that you can see is 1 to 1.5. And this one is 3. It's 3. It's 3. So how about this distance?
4.5.
What? 4?
4.5.
Okay, 4.5. Great. Okay, so now we use the scale ruler to measure a distance the same with 4.5. Okay, so almost this. Okay, and I will put this line here and then draw the vertical line. Okay, and as for this one, it's the same. Okay. Okay, so as for this one, this circle, so it's important for us to calculate the horizontal distance, because this one is 1 to 1, or 1 to 1 is 1 to 1 the slope. And the difference of the our region is 3, and the horizontal distance is also 3. Yes. Okay, so now please use this. Please, I will draw another ruler. I have to use this ruler and measure 3. It is 3, almost right. And then I will rotate. Okay, so wait for a moment. I first I will draw you can see this is a radius. This is a radius from the center of this circle. Okay, and then I will rotate it and measure the distance is 3. Yes, this distance is 3, and then I delete it. And now please use compass. Use compass. Draw a circle. Because here is no compass in the whiteboard, so I use this one. I use this one as a example. It's not very actually, but just the meaning. Okay. Okay, so like this or like this. Okay, so you can see we have the cross point of the curve and the straight line. So I trim it. I trim it. Okay. So how about next? The next one is to find many lines. For example, at first we are going to find a control line with is 3, 2, 1, 0. Okay. Maybe I have to draw a control line with the elevation of 1 like this 3 2 1 the same you can see 3 2 1 okay like this. And also we have to draw a circle with radius. The difference of the radius is 3 to 1. Okay, like this, just like this. And then like this. Oh, it's so small. Okay, so you can see this this line is 2, and this line is 2, and this one is 1, and this is 1. So please, I think this is not very nice. So you please connect this point, and you can get it. You can get it. Okay. So this one, and I have to move it. Two. Okay. 1. Okay. And then connect this curve. Okay, so you can see this is the intersection line between the cone and the plane, between the surface of cone and the plane. Okay, can you get it? You can see the cross point is the same contour lines cross point, and then you will get many if you draw many contour lines, you will get many points, and then you please you can connect these points together. It is into a curve. So that curve is the intersection line of the cone surface and the plane. Okay, so can you get it?
Yes.
Okay, so it's not very difficult. It's not difficult. Okay. So because I can actually I can draw more lines in this interval, but it will be not it is not efficiently. Okay, so let's have a rest. Oh, yes. Oh, yes. Okay, good job. Oh, good job. Mm. Okay, no problem. Check. Okay, 20 students. Okay, and I think that now all of you have understand how to draw the intersection line between the plane and the surface and the curved surface. Okay, so as for the regular one, for example, the curved surface, the surface of a cone is a regular one, But I think as for this one, is irregular one, is the same way to draw. Is the same way to draw. The key point is to find the point, the cross point of the same contour line, and then connect these cross points together. So you will get a curve. That curve is just the intersection line between the irregular surface and the plane. Okay. So let me see another example. For this one, you don't. So this is complex. So you can look at it. Can you imagine what the shape of this one? So you can see this one is this one is a plane. A plane that the elevation here is 13, 12, 11, 10, 9, and this direction is a descending direction. And this green circle, is what? Is a plate. Is a plate. Is a circle plate, and its elevation is 8. You can see this elevation is 8, and because we have to keep it stable, we have to support this plane and then excavate the slope about this plate, about this plate. So now you can see as for this one, you can see the supporting slope. Supporting slope is with a slope of 120.7. So if we want to find the cross line between the plane and the surface and the curve, so at first we use this center. We use this as a center and draw many circles. And the circles with the interval is 1 to 0.7 and equals to so what is 1? The horizontal is 1. You can see. So I draw here. Oh, it's so small. I draw a larger one. Okay. Okay, you can see this one is 1 to 0.7. The slope is equal to the slope, and the difference of each contour line, the the difference of elevation of each contour line is 1, because you can see there is 5 to 6, the difference is 1. Also 7, 6, 8, 7, 9, 8. So each contour line's interval horizontal distance interval is 1 multiply 0.7 is 0.7. Okay, so you can draw a circle, and this interval is 0.7, and this one is also 0.7, 0.7, and 0.7. And all of these contour line with the has the same center, have same center is the center of the plate. Okay, so you can use a compass, draw many circles, and these circles are contour line, and the same circles you can see this edge, this elevation of the edge is 8, the 8, and this one is 7. So this contour line's elevation is 7, and this contour line's elevation is also 7. And please note, note it at point 7. This one and this one, they are two. And with the same procedure, you can find the cross point with the contour line's elevation is 6, and the same one with 5 and with 4. So connect them together, and you will get a intersection line between the cone, between the surface of a cone and the surface and the plane and with the same procedure, you can draw this one at the bottom, at the below the plate, at the top of the plane. So it is, you can see this is the line that we have to excavate. We have to excavate along this line, and then fill the earth at this area. In this area, we have to fill, and here we have to cut, and here is a plate. Is a horizontal plane. Okay, so we is a two-dimensional surface, and I will show you the real one. Okay, so please wait. I will show you the real one. Okay. Many. Okay. No. Okay, this one. Please wait for a moment. Okay, that's it. You can see this one. This one is the same. Okay. I'll closed some. I have to close some pages. So my computer is very slow. And close. Okay, so now you can see this is the same with this one. And can you imagine what it's like in the three-dimensional space? Okay, let me show you. I change it. Okay, so you can see that is the I will use the conceptual. Oh no, realistic. Okay, see, you can see here is a slope. Here is the slope of a mountain, and here is a plate. Is a circle plate. Rounded plate, and at the bottom of this plate, we have to fill the earth to support this plate to keep it stable. And as for this one, we have to excurve. We have to excurve. Then we will get obtain this plate. We'll get this plate. So that is a three-dimensional wheel. Three-dimensional wheel of this figure. Okay, so please think about it. Okay, so this one is good. So that is why we have to know the excavation line and the 14 lines. So because if you once you want to build building, you have to do a building, and you have to excavate a pit. Also, you have maybe sometimes you have to fill an embankment, a dam. So you know the shape of this object, of this construction, and you know the slope, and so you have to find how much the area, the shape of the area, the shape of the ground we have to occupy to build this construction like this. So for example, we know the shape of this plate, and we know we have to and we know the cutting slope and the filling slope, and we can calculate the area we have to cut and the area we have to fill. Okay, so so that is the way to find the intersection line. Okay, so that's it. Okay, next time, next week, next step, we are going to learn the same slope surface. Same slope surface, it's not very common. Usually in a construction, like the rib, you can see this is the same slope surface. Here. The same slope surface is a curved surface, and it is a curved surface and with the same slope at every point. You can regard it as a part of the surface of a cone. It's a surface of a cone. Usually, so as for this road, and the embankment has the same slope at each section, but the line is a curve. But the line is a curve. So the surface of the embankment is also a curve, and it is usually the same slope surface, like this, like this part. Okay, so we have learned about the contour line and the contour line of a plane, the contour line of a cone, and the intersection line of the plane and the plane and the plane and the surface of coin of a coin, and then we are going to learn how to read the contour map, so it is the properties of the contour line of the topographic maps. Irregular surface. Usually, we can see the mountains in rivers in the real world is not a regular surface. Not regular surface. It is irregular surface, and the contour line is not a regular curve. Is not a circle, and is not always is not a straight, and so it is an irregular curve. For this one, you can the contour line, the contour width is equally spaced, represents a uniform slope, whereas one which is closely spaced represents a steep slope. For example, as for this one. So, as for this one, I draw two lines. And for this one is line A, and for this one is B. So who can tell me which one is more steep? Which direction is more steep?
Between which one and
The line A is more steep, or line B?
Line B.
Oh, it's can you understand what is the steeper or gentle? Or gently? The steep, gently. Yes.
Yes.
For example, this one, we say this slope is, and this slope, this one is gently, and this one is slope. This one is steep. This one is steep. A, yes, A is more steep. Why? Because you can see this point elevation is 60. This one is 60, and this one is 10. And the distance, the difference of the elevation are the same as 50. But the I is equal to h to L with h divided by L, and you can see the L A is smaller than LB. So A is bigger than IB. IB. So the line A is much more steeper. Is much more steep, and B is more gently than A. So you can see the density of the contour line can represent the represent the steep or of the slope or not. Okay, so it's hard for me to translate. To translate. So please remember. With the same difference of the of elevation, the horizontal distance is bigger. The horizontal distance is larger. The I is smaller, and the slope is much more gently. And if with the same h, if the L is smaller, the I is bigger, and the slope is more steep. Much more steep. Okay. And there's another characteristic for the contour line is the contour at any point is perpendicular to the line of the deepest slope at the point. So if you want to find the deepest slope from this point, okay, for example, if I want to from this point, I want to find the deepest line. It is must vertical to the contour line. It's must vertical to the contour line. As for the A, B, C, D, E, and then the I, D is the biggest. And the D is the steepest slope. If we want to go down this hill from this point. So that is the characteristic of the contour. So you with this rule you can find the deepest route, the deepest route on a mountain. Okay, and as for this one, can you get this one is a top of the mountain. This one is the top of the mountain, and this one is a valley. This one is valley, and this one is rigid. This one is rigid. R I G O. Rigid. I-G-I-D. Rigid, yes. And this is top. And for this line, we call it is valley. So this is the very common shapes on the ground. So you can think about it. This is a top, and this is rigid, and it's a valley. And if there is a river, it is usually at valley, at the position of a valley. The river will the water will flow from top to the bottom. And as for this one is the rigid is like this one. Okay. So I will show you another map is like here. Yes. What I said is the top and the the valley is here, and the rigid is this line, So let's come back to this figure. So so you can see the difference between the rigid line and the valley line. Like this, I have sent you the YouTube the videos on YouTube that can explain it very well. I think it explains this point very well. You can see it's the shape of the contour line is like a V. It's like a V. V from this direction, and the top of the V, towards to the descending direction of the contour line of the descending direction of the elevation. It is a rigid line. And as for this one, you can see there's many shapes like V. But for this shape, the top of the V towards to the increasing direction of the elevation. Increasing direction of elevation. So that is a valley. That is a valley. So I hope that you can understand this. Okay. And then it's another direction to see this mountain from this direction. You can see the cutting plane of this mountain. So you can see this is like a shape of mountain here. Also, here is this line is a Manet cutting plane. So as for road, you can see sometimes we have to fill, and sometimes we have to excavate. So this line is a road. It's a top view. And usually the slope of the road is the same, and so with the original contour lines, and we can get the excavation line. We can get the excavation line. The green one is the excavation line. Also, you can see the cut wheel of 1. You can see 1 1. A is here, and B is here, and the road is at the bottom of this one. So A is this direction the slope, and usually the slope we already set it as 1 to 1 or 1 to 2. 1 to 2. It depends on the on which kind of the stone, which kind of the soil alongside with the road. Okay, so in the next week, we are going to learn how to read the map of a construction. How to read the engineering drawing of many different construction, including the road, the building, and the bridge. So this is the basic knowledge to learn how to read the construction drawing, construction drawing. Okay, also, so that let me show you an example. Let me show you another example about the topographic drawing. Okay. Let me show you. Which one? Okay, this one. Okay, so now I will use it as an example. So you can see this is a contour map. Okay. We use the two-dimension. It's a contour map of a road. For example, from this part, from this point is the start point. We want to build a road through this mountain, the river, the pond, and so on, and many graphics, many places. As you can see, this is like a river, and sometimes it may be a valley. It's a valley, and so at first you can see for this one, who can tell me where is it? What is it? It is a valley. It is a valley, rigid top. This part.
Mountain.
Yeah, it's a mountain. Of course, it's a mountain. It's a top. This point is the top of the mountain. So how can we get the elevation? You can see there are many figures on the maps. You can see there is almost is 300, 300 and 308 and 8. And so you can see from the bottom to top, the elevation is increasing. So it means that this point is much more higher than others. So this is the top of the mountain. Okay. Okay. And I will find another one. So like this, I will find another one like this. How about this one? If I draw a line from here to here, how about this one? This is a rigid or valley or others. Who can tell me? This one.
Valley.
This one is yes. Yes, it's a valley. Yes, of course. Okay. Oh, this file is so large. It's so large. Yes. So let me tell you why this part is a valley. So because you can see this point is 278.9, and this one is 208, and 68. So this one is lower than this place. So if there is a water, there is a drop. If there is a drop of water, the water will flow from the top to the bottom. So you can see, and the shape of the contour line like this is a V, and the top of the V is towards to the increasing increasing direction, So that is a valley. So let me find a rigid. This one, I think this one is a rigid because this is a top, and from this point to this one, here is a rigid because the top, the direction of the contour line towards to the descending direction, because you can see here is a 300, almost 300, and here is 280. So here is a rigid, and just now on this place, this one is a valley. And as for this one, is a top. So for this one, I label it as a red line. So can you tell me what's this? It's a top, it's a valley, and it's a rigid, and any other kind of shape.
Valley.
What? It's a valley? No, it's not a valley. I think it's not a valley. So at first, let me tell you. At first, you have to you have to check the elevation. You can see the elevation here is 268. But around this area is 279, 281, 278, and 270. So all the places are higher than this point, than this point. So this is, I think this is a how to say, it's a basin, BASIN. Is right? Let me check. A basin. Yes, a basin. It's this. It means that these places are lower than the ground, than the around, and so it is inverse. It is inverse to the top, to the top. Just like these two one. You can see, this is the top and this is the bottom. Okay, so now maybe you will understand what's this. Because the elevation is lower than the others around this area. Okay, so now we can read this contour map easily. Okay, so today we have learned the surface, the contour line of a cone, and the contour lines, and how to get the intersection line between the plane and the contour line. and the cone surface and I think that some of you do a good job. I have seen that you have do your homework very well, and we have learned how to read the control map. So of course today well, I have prepared to explain this homework to you, but time is not enough. So I don't worry. I have put it at this next in the next class. So I think it's you better to think it about yourself carefully. So you can see this is the answer, and you can check how to get it. You can think about how to get it. This is the answer. This is the answer. Okay. So today is finished. This class is finished. Okay. So thank you very much. Okay. So see you. Class is over. Okay. See you. Have a nice day.